Hi, I'm Chelsea, and today I'm going to explain and demonstrate with an example how to use the quotient rule to take the derivative of functions. So first, before we jump into our example, let's first look and see what the quotient rule tells us. To use the quotient rule, what we generally look for is a function where we have another function divided by a third function. So, in terms of h's and f's and g of x's, I'm going to define our big function that we want to find the derivative of called h of x. And h of x is made up of f of x divided by g of x. So, to find h prime of x, the derivative of h of x, the quotient rule will allow us to do the following. It tells us that to find h prime of x, we're going to take the bottom function, g of x, multiply it by f prime of x, the derivative of the top function, subtract from that the original f of x, so the original top function, multiplied by g prime of x, the derivative of the bottom function, and then we're going to take that entire difference and divide it by the bottom function squared, so g of x squared. Now this is often hard to remember, and unlike the product rule where the order doesn't matter and which function you define g of x and which function you define f of x, in this case the quotient rule, because of this minus sign, we have to be very careful. What I often play in my head is low, d high being the derivative of the high one of the top function, minus high, d low, so the derivative of the bottom function, all over low squared. So it's a little jingle that I often remember that could very well help. So again, that's low d high minus high d low all over low squared. Okay, so now that we have that, let's look at an example on how to use that. So here's our h of x, and this clearly is a polynomial divided by a polynomial. So this is a perfect scenario in which we want to use the quotient rule. So first, let's define f of x and g of x. Again, we have to be very careful, and especially if we use our definition like this, to make sure that we call f of x the right function and g of x the right function. We just don't have the freedom we did in the product rule. So in this case, our f of x is going to be our top function. So f of x equals 5x squared. G of x is the bottom. So that'll be x cubed plus 1. Okay? Again, I like to just keep writing here, making a list of all my functions and their derivatives. So let's find f prime of x while we're here. So f prime of x using the power rule will be 10x. And g prime of x, in this case, bring the 3 down in front and drop the power, 3x squared, and the derivative of 1 is 0. Okay? Now that we have all that, let's stick this back up into our definition of the quotient rule, to find h prime of x. So, h prime of x will equal the low function, the bottom function, so in this case that'll be x cubed plus 1 times the derivative of the top, f prime of x, minus the top function, f of x, so 5x squared, times the derivative of the bottom, g prime of x. And we're going to put that all over g of x, that whole thing, and use lots of parentheses, squared. Okay? It's very, very important that, especially when using the quotient rule, that we use our parentheses so that terms don't get multiplied that shouldn't. We want to keep our functions nice and contained before we go on to simplify them. So at this point, we've done the calculus. We've taken the derivative of h of x. But normally we don't stop there because we want to simplify this just a little more. When you have polynomials, typically what we try to do is see if we can combine any like terms in the top. I wouldn't yet touch the bottom, that polynomial squared, unless we absolutely need to. But if we simplify the top, factor things out, sometimes things will then simplify. So all I'm going to do here in the top is just use the distribution on each of these and then combine like terms. So first I'll just distribute this 10x to get 10x to the fourth plus 10x minus, and then multiplying those two terms, we'll get 15x to the fourth. And again, don't forget your bottom. Okay. Just writing everything nice and neatly. I'm going to kind of move up here for some more room. And then looking at the top again, I can combine these x to the fourth terms. So we'll be left with, and again, this is each prime of x that we're simplifying, a negative 5x to the fourth, okay, combining those two, plus a 10x. Okay, and that's all over x cubed plus 1 squared. And just to check, I'm going to look at the top and factor out a negative 5x. So we'll be left with x cubed from there minus 2. And at this point, because the top is factored and the bottom is factored, we see that there's no terms that are going to cancel each other out. So this would be our simplified form for h prime of x. Okay. And that's it. That's how you use the quotient rule. Again, remember, it's very important that this f of x and g of x are specifically defined. Okay, you need to make sure you know which is the top and which is the bottom. This minus sign can mess things up if you were to flip-flop them. So you want to be careful with that. And that's it. For more information, please visit our website at www.sandersontestprep.com. And the link is in the description below. Thank you.